And what we're going to do in chapter 3 here is that we're going to talk about Newton's second law, which we call N2L, and Newton's third law, which we call N3L. I think this chapter is a game changer. I think there's a lot of really, really good stuff in this chapter. And what we want to sort of like look at in this chapter is I kind of want to sort of like summarize where we were and now where we're headed. So the first thing that I'll do here is that, like I said, I want to do a summary. So if I summarize what we've done, it goes something like this. What we did here is that we said if you're at rest or at constant velocity. We then said that this was a state of acceleration of 0. And because you're in a state of 0 acceleration, this net force is 0. When we say that, what do we mean by that statement? What we say here is that we are in what? Force-free motion. Now, the thing about it is that, oh, I didn't spell force right. So I need to add a C. So what we're going to find here is that I'm going to use different language. I'm going to call it equilibrium as well. So I'll say force free, but you'll also hear me say equilibrium. So what does this mean? It means no net force is required to be in these states of motion. So no force is required to keep it at rest or moving at constant velocity. And then we came in here and we drew the line. We come in here and we say, this is the line. If you cross this line, it means what? You're not at rest and you're not at constant velocity. So you're doing what? You're speeding up, slowing down, or turning. And if you do that, you are now non-zero acceleration. In other words, what we say, you're in accelerated state of motion. You're in an accelerated state. What does it mean to be accelerated? Well, it means that the net force now is not 0. What does that tell me here? That you are in what? Forced motion. What do we call forced motion? Not equilibrium, but non-equilibrium motion, or a non-equilibrium thing. So what this tells us here is that this kind of motion requires a net force. Over this is what we call N1L. Right here, we call this N2L. So when you look at this thing, you're going to find that Newton's second law tells us what causes acceleration. Since acceleration is a vector, we have to talk about the magnitude of the acceleration, and we have to talk about the direction of the acceleration. So that brings me now to Newton's second law, N2L. So what does N2L tell me? It says this: when a net force acts on an object, the object accelerates. According to the magnitude, we then say that it's the acceleration. And this acceleration is caused by this thing called the net force divided by the mass. So remember, equations are just sentences. We want to convert it into a picture. So when I look at that acceleration, what is the cause of the acceleration? This causes the acceleration. Okay? This causes the acceleration. On the other hand, there's this thing called mass, which we will talk about. And what this does is that it scales the acceleration. They play different roles. Note that this is the first time that we've talked about mass. So if you've taken physics before and they say that Newton's first law is about mass, then why didn't it show up in Newton's first law? Why isn't mass explicitly written in Newton's first law? It's not. It shows up in Newton's second law. So what you're seeing here is that now I can write an equation for the acceleration because that's useful for us. So then picture-wise, it says the acceleration is equal to the net force divided by the mass. Or I can write the net force is equal to mass times acceleration. So it turns out that this is what we're going to be using most of the time because we want to draw pictures of these equations. Of course, not solving them. So then, because acceleration is a vector, we need to talk about the direction. So what about the direction? It says this: the acceleration is always in the direction of the net force. It's always in the direction of the net force. This is Newton's second law right here. Okay, this is Newton's second law. So what I'm going to do here is I'm going to box this up because we're going to use this a fair amount. And there we go. Newton's second law. One thing that I will say here is that your worldview is actually in this equation right here. Your worldview is about Newton's second law. So what you'll find here is that physicists say that Newton's second law is called the law of common sense. Your interpretation of everything is without any doubt in this law right here.